Here is inverse hybrid parameter model for two-port network. Now, here is an example on inverse hybrid parameter. The example says that find the G parameter G11, G12, G21, G22 as a function of frequency domain for the circuit shown below. Meaning that this circuit is given a time domain, your answer should be in the frequency domain, S domain. This diagram is given in time domain, going by the units that we have. We have 1 H, 1 Henry, and 1 Hertz, 1 Farad of capacitor, and then 1 ohm resistor. Now, from the Laplace transform, we already know that if we want to convert from T domain, time domain, to frequency domain, we have to use certain formula. For your inductor, to calculate your inductor, you have to use S multiplied by your L, SL. And for your capacitor, it will be 1 over SC, but your resistor remains the same. And so for your SL, that is for your inductor, your S multiplied by the value of your inductance, or the inductance of the inductor is 1 Henry, so 1 multiplied by S, you have S. And for your Farad, 1 over S multiplied by 1 Farad is 1, so that gives you 1 S. Now to calculate for your G11 and G21 from the formula of inverse hybrid parameter, remember, from I1 equals to G11 V1 plus G12 I2, to get your G11, your I2 must be equals to 0. That is, you must have an open circuit. Also, to calculate for your G21 in V2 equals to G21 V1 plus G22 I2, your I2 must be equals to 0. That is, you will place an open circuit at the output of your diagram, that is equate your I2 to be equals to 0, and you will place a voltage source, a voltage at V1 at the input side of your diagram of the circuit. Now, doing this, you can easily calculate using Ohm's law. You can calculate for your VI1, that is the input voltage, or your input current. Either of the two you can calculate using Ohm's law, and you will get your I1 equals to V1 over S1 plus 1, or your V1 equals to S plus 1, or bracket I1, using Ohm's law. Now, another thing I must point out is that when you have already converted your diagram from time domain to frequency domain, you treat every element, whether resistors or capacitor or inductor, you treat them as if you are treating a resistor. That is, you had them the way you normally had a resistor. Also note that your capacitor is no longer in the circuit, because the current flowing through the capacitor will make it to be open. Is already open circuit. That means the current flowing through it will make it to be open circuit. It will be 0. That's why the capacitor is not included in our calculation, because it's already equated to be 0. Don't forget we are calculating for our G11 and G21. And our G11, which is our open circuit input admittance, is equals to I1 over V1, that is input current over input voltage. We already calculate for our I1 to be V1 over S plus 1 in slide 14. From that slide also, you can just change the formula and get your V1 to be S plus 1, or bracket multiplied by your I1. So you either have the choice of substituting for I1 in this equation, G11 equals to I1 over V1, or you substitute for your V1. Either way, you will get your G11 to be 1 over S plus 1. Get your G11 to be 1 over S plus 1. Now, your G2 your G21 sorry, your G21, which is your open circuit forward voltage gain, will be V2 over V1. Be V2 over V1. Your V2 is the voltage across the 1 ohm resistor. Using the voltage divider principle, you will get your V2 to be 1 over S plus 1 multiplied by your V1. 1 over S plus 1 multiplied by your V1. Remember, the capacitor is no longer there because the current flowing through it is equal to 0. That's why the capacitor is no longer there. So for your V2, we have 1 over S plus 1 V1. Substitute that into G21 equals to V2 over V1. You have 1 over S plus 1. 1 over S plus 1. So your G21, your open circuit forward voltage gain will be 1 over S plus 1. To obtain our G12 and G22, we will place a short circuit. Our V1 to be equal to 0, we'll place it at the input side of the circuit given, and we'll also place current source I2 at the output side of the circuit given in slide 13. So when we do that, we will see the circuit shown here, and from that circuit we can see that we have our I2, which is the current source I2, flowing, and is flowing through the capacitor, which has been converted to frequency domain 1 over Hertz, and that also, when it gets to the junction, it splits into two. A part of it flow into the 1 ohm resistor, another part flow into the inductor, the S inductor, and that part that flow through the S inductor is represented by I1, but is flowing in opposite direction. So by current divider principle, we can calculate our I1, and that will give us minus, because it's flowing in opposite direction, minus, using current divider principle, 1 over S plus 1 multiplied by the total current flowing in this circuit, which is I2. So substitute that into our formula. Our formula for the short circuit reverse current gain, that is G12 equals to I1 over I2. Our I1 equals to minus 1 over S plus 1 I2 divided by I2, and so we'll get minus 1 over S1 for our short circuit reverse current gain. Our G22, to calculate it now, our G22, which is short circuit output admittance, is equals to V2 over I2. Remember that V2 is the voltage in the circuit, and using Ohm's law, V equals to IR. Our V2 will be I2 multiplied by the equivalent resistor. The equivalent resistor, just like I told you that when you've converted to frequency domain, you treat every element, whether capacitor, inductor, resistor, you treat them as if you are treating the resistor. You add them as if you are adding resistor, multiply them as if you are multiplying resistor. So we have our equivalent resistor element there. We see from the diagram in slide 16, we will see that our capacitor is in series with the inductor and the resistor in parallel. Again, the resistor and the inductor are in parallel, and they are both in series with the capacitor. So when you add that together and then you multiply it with, you multiply, that is, find the parallel combination of your inductor and the resistor, and you add it to the value of the capacitor, you should get S squared plus S plus 1 over S bracket S plus 1 multiplied by your I2. So your G22 will simply be your V2 over high 2 and the high 2 will cancel out. So you will simply get S squared plus S plus 1 over S bracket S plus 1 as shown. So in matrix form, this is the matrix combination of the different inverse parameters that we have calculated so far. So it will be 1 over S plus 1, that's G11, and minus 1 over S plus 1, that's G12, then 1 over S plus 1, that's G21, and S squared plus S plus 1 over S plus S bracket S plus 1, that is G22. So we can see from there that's our G12 and G21. G12 and G21, they are reciprocal because your G12 is equals to minus G21. That's a situation for reciprocal.